Bonjour Hanan. Bonjour Hanan, tu m'entends?
Bonjour Céline, vous m'entendez? Vous arrivez à m'entendre? Céline, vous arrivez à m'entendre?
C'est bon, maintenant c'est bon. Donc on va présider cette session ensemble.
Exactement.
Ok, donc
c'est un plaisir de se revoir dans ce cadre aussi.
Le plaisir est partagé.
Merci beaucoup. Donc, je pense qu'on a 5 articles.
Hein?
On a 5 articles dans cette session.
Exact. Donc on va commencer par voir s'ils sont là déjà. Et
oui,
après,
on vérifie qu'ils sont là.
L'expérience a montré qu'il n'y a pas beaucoup
d'absents et accès.
C'est ça. Donc, il faut chercher quelques questions pour encourager un peu les participants.
D'accord. On vérifie la présence déjà?
Oui. Ah, ils sont là. Ok, donc...
Donc, je pense si Yassine Amkaran, vous pouvez nous répondre si vous êtes présent?
Je peux m'en occuper.
D'accord.
On va laisser encore 2 minutes et on démarre.
Pour les retardataires, ok.
Oui, un petit peu. Oui, mais ok. Good evening, everybody. My name is Eloj Mohsin. I'm from IMI, Mohammed Fifth University. I chair this session with Professor Hanan Baqali from INSEAS, Mohammed Fifth University. Before we start, I would like to see if every speaker is here. The first article, I would like to know if Yassin Amqaran, Mohammed Al-Aoudi, and Mohammed bin Jelloun are here. If you hear me, please say something. Okay. Second presentation is Nicola Lewis and Joaquin Vieira.
Yes, I am present.
You are here? Okay, thank you. The third is Karim El-Mutawakkil, Abdellatif Louisari, Abdullah Touhafi, and Nabil Aharan. Are you here? Apparently no. The fourth is Asma Orhim, Jihan Lakhourit, and Karim Beina. Are you here in the room?
Asma Warhim.
The last paper, Jalal Rafiq Hamou, Sidi Ahmed Mahmoudi, Rida Adjouj, and Boubacar Mshab.
Présent.
Okay, thank you.
Yassin Amkran also. I'm present.
The first.
Yes.
Okay, the first. Yassin Amkran?
Yes.
Yes.
Okay.
I think for Yassin Amkran, it's a video that should be present.
Yes. Yes,
okay.
It will be
okay. The second time I asked the third presentation, Karim Al-Mutawakkil, Abdellatif Al-Wawisari, Abdullah Touhafi, and Nabil Ahran. Are you in the room? Okay. And the fourth is Asma Orhim Jihan.
Present.
Are you here? Okay.
Okay.
Asma, are you here?
Yeah, I'm
Okay.
here.
Thank you. So it's still the third one, but we can begin. We can start with the first paper. Again, welcome to this session. You have 15 minutes for presentation and 5 minutes for question. When it's still 5 minutes, I activate the video, so we will be able to see that it's you have to finish. And we begin with the first presentation of this session. Presentation entitled Toward Breast Cancer Response Prediction Using Artificial Intelligence and Radiomics. The authors are Yassin Amqaran, Mohammed Al-Adoui, and Mohammed bin Jalloun. Go ahead. I understood that they have a video. So
Yes,
I ask the room manager to play video, please.
Okay. The voice is missing, the audio is missing. I didn't hear anything.
Me too. So please, the room manager, if you can do something. We don't hear sound. We see only the image.
Please, could you check the audio?
I don't hear. Do you hear something?
No.
No audio on my side either.
Hmm?
No.
Maybe
The problem persists.
maybe Yassin, you can comment the video.
Yes,
Is it
but
possible?
yes, but today I'm sick on my throat, so I cannot present. I cannot speak for more than 5 minutes.
Okay.
Yes, but if
Another try before switching for the next author.
Yes. So please.
and if not okay, I can comment. So no problem.
Okay.
Okay.
We try last time. Maybe we-
Je reviens dans 10 minutes, si vous me permettez.
There is a message that that said that the sound of the heart is mute.
So,
The sound of the heart
the heart.
is mute.
Maybe-
yes. So if you want, I can comment. So it's better to,
Are you ready?
yes, I can try to comment, yes.
Okay. So when it starts, you can.
Okay.
We need the presentation to be shown. The presentation is
We
is
can
not
play.
yet on the screen.
Hanan, we can play the video,
Yes, you can play the video and I
He
will comment the video.
and he comment the video. Maybe it's
The
possible.
room manager could try just the video without audio, and Yassin Amkran will present. Please, the room manager, could you? Yes. Okay.
Yes.
So Yassin Amkran,
Okay,
please go ahead.
go ahead.
So, hello everyone, I am Yassin Amkran. I am a PhD student at the University of Mons, and I am doing my thesis on medical imaging. I am working exactly on the prediction of breast cancer response to chemotherapy using radiomics. Today, I present our work, so our first work, and I would be happy to have your comments and suggestions to advance with in my thesis. So my presentation will be according to this plan. First, I introduce the topic of the article. Second, I talk about the context of the thesis. Third, I present the data, so MRI imaging that we are processing. Fourth, I detail our method, but also the methods that we have to study in state of the art. Fifth, the results that we have obtained. And finally, the conclusion of our work. The results that we have obtained, and finally the conclusion and future work. As you know, breast cancer is one of the most important health issues. So I think that sound now is okay.
Yeah, yes, I think so.
Okay. Is the ability to provide practical and effective treatment. Thus, the application of image processing and deep learning on medical images will, of course, facilitate the task. In 2018, according to the World Health Organization, more than 620,000 women die from breast cancer in the world. One of the main treatments for this pathology is neoadjuvant chemotherapy, which attacks cancer cells and reduces the size of the breast tumor to facilitate surgery. But the systematic drug treatment has side effects, and also breast cancer or cancer cannot respond to it. So our goal is to predict breast cancer as soon as the tumor appears and help oncologists to make quick decisions based on breast tumor response to chemotherapy in the first cycle of treatment. That means after the first chemotherapy. Our work will be applied on Queen Breast DC MRI provided by Oregon Health and Science University. It presents a public database composed of more than 30 breast cancer patients. This database contains MRI images of longitudinal study, allowing to assess breast cancer response to neoadjuvant chemotherapy. From this collection of MRI images, in the beginning we use in our first study we used 2 MRI sequences, so T1 MRI and T2 MRI. Several methods are such that texture analysis and histogram analysis and also parametric response mapping. For example, for PRM, it's a method used by my colleague Mohamed El-Adwi. This method is based on 3D affine registration, which allow aligning the DCMRI images section, so no response, positive response, no response, and negative response. Acquired before chemotherapy and after chemotherapy, and to carry out a voxel comparison by voxel to identify the percentage of intra-tumor response with a 3-color card, as I said, so negative response, positive response, and also region that there is no response. And one of the solutions used to predict the cancer response to chemotherapy is radiomics. It's a field of medical study that aims to extract and analyze qualitative and quantitative features from medical images. The method that we will follow is, so first is the data preparation, second pre-processing, third, and is the most important step for us, is radiomics. So we use radiomics as approach to the 4 MRI sequences acquired before and after chemotherapy. So now we use just 2 MRI sequences. After this, the segmentation of tumor, and after this, future extraction. So we will extract the characteristic separately before and after chemotherapy, and finally we will do a radiomics analysis. So automatic learning method will be applied to compare the extracted characteristic to the chart in the file. And finally, so response prediction to help oncologists to make a quick decision. So first, data preparation. That consists on the selection of 4 MRI image sequences acquired before and after the chemotherapy session. So now we use just 2 MRI sequences, T1 and T2, but after we will use DW MRI and also DC MRI. These are then normalized in order to ensure accurate results. Second, pre-processing. This step consists of segmentation of breast tumor before and after chemotherapy. This segmentation is followed by a data augmentation method in order to have more data. So third, radiomics, and is the step the more important in our work. So in this step of applying machine and deep learning methods, so to extract future by deep learning and also by machine learning, we will do so a comparison between these 2 methods. Then we can select the most important features before applying the radiomics approach for breast tumor response prediction. And finally, we do a radiomics analysis. So we analyze the features. And finally, response prediction. The resulting features are used to propose a new model for breast cancer response prediction,
with a complete visualization in order to help oncologists to make accurate and fast decision. So visualization and also. Currently, we segment tumor in breast MRI images using the results of our previous deep learning method based on unit architecture used by my colleague Mohammed Iladwi. So, according to the state of the art, we believe that radiomics can provide results to predict chemotherapy using to predict the breast cancer response to chemotherapy using MRI images. We plan to explore radiomics algorithms to extract the most important features of this method. However, the data set in this file still limited to validate the developed method, but we will use also data of Gilbert Institute
Okay, thank you.
So thank you for your kind attention.
Thank you. So I think we have more time for questions. Are there any questions?
I have a question. I just would like to ask, how did you obtain your data?
Yes, in Amakran, do you need the
Yes. So
Sorry,
what?
question
like
was
to ask-
repeated, please? Could you repeat your question so Yassine
sure.
could answer?
I'd just like to know, how did you obtain your data?
Yes, for data for my first work, I use the data for clean. So in article, I mentioned the website of data.
Okay, okay. Thank
Okay, and after this, I will use data of Gilbert Institute on Brussels. So because we have collaboration, so for our department, we have a collaboration with the Hospital Institute in Belgium. So I will use their data because for this this first database, there is just 30 patients and is not enough to do this work. So we need data.
Yeah, okay. No, I understand. Thank you so much.
I agree that the data set is very important. Perhaps you need to compare with other data sets. I think there are lots of data sets.
Yes. So we have the data set of Gilbert Institute, and also thanks to the work of my colleague Mohammed Iladwi, we have also a collaboration with the USA Institute, and we have more than 200 patients. So we have enough data to do our study, to do radiomics analysis. Other question?
Yes, I have a question. How about the time consumption or the algorithm complexity?
Yes, so now I just work on segmentation on images, so in tumor segmentation. After this, I will work on future extraction, and I will work with the GLCM method and BLP method, but now I don't have any idea about the complexity of algorithm that I will use, because I will first I will test, and after this I will say. But in the beginning, I will use the method that exists and so algorithm that exists.
Okay.
Other questions? So, Madam Ilbakali, we don't intend you because your micro is not.
Oh, sorry.
Okay.
Yes. I could repeat my question. Is about pre-processing.
Yeah.
We know that pre-processing is important to obtain data with higher quality. And you mentioned in your presentation I think 2 steps, normalization and segmentation. Is that true?
Yeah. So
Perhaps you need another step. No? You don't think so?
you talk about data augmentation?
I think in the literature there are many pre-processing steps that are used to obtain higher quality of data. I'm just asking, so in this field of images of breast cancer.
Yes, so what we do another step. It's it's to make sure, I forgot the scientific name, but to make, for example, we have images before. I talk about recalage. Recalage of images. So is that we do some, we modify the form of images. For example, we have image before chemotherapy and image after. So the both of the 2 images are not the same. So we do recalage, is that some like form transformation to, for example, images after, to do after this like superposition for the both. Yeah. But I don't mention this step in my presentation because my colleague Mohamed El Adoui do this step in his work.
Okay.
Yeah. Because after this, so now I work on with the public data set, but after this I will work with Gilles-Bordy data set. And for this data set, my colleague Mohamed El Adoui has prepared this data set with the segmentation, recalage, and also he did the data augmentation.
Okay, thank you. Are there any questions in the audience? I think we should thanks Mr. Amkran. Thank you.
You're welcome, and thank you.
Thank you. Mr. Rej, Professor Rej. Professor Rej, did you hear me?
Yes. Okay, the next presentation is entitled An Image Processing Player Acquisition and Tracking System for Esports. The authors are Nicolas Lewis and Joachim Vier.
Yes, that is me. Would you like me to share my screen, or will the host share the screen?
If you can share your screen, yes.
I'll do that. I'll do that.
Yes, please.
I'm sorry, but the audio is not working.
All right, no problem. I'll just see if I can get it to work here.
Okay.
All right, there we go. Should be working now. Let's try again. Good day. My name is Joaquim Vieira, and my co-author is Dr. Nicolas Lewis from the Central University of Technology. The title of my paper is An Image Processing Player Acquisition and Tracking System for Esports. Where did it all start? Electronic sports or esports and gaming tournaments all began back in 1972 at the University of Stanford, where the researchers at their computer science laboratory designed and created the Space War game and held the first ever gaming tournament in that year. This was followed up in 1978 by Atari by the first ever Space Invaders gaming tournament, and this was the first ever competitive gaming tournament. The success of the video game industry is no thanks to these major gaming competitions that have been held every year for various games such as Fortnite, Counter-Strike, Global Offensive, Dota 2, Call of Duty, and so many more. In 2017, Counter-Strike held the World Electronic Sports Games, which had a prize pool of $1.5 million US. In 2019, Fortnite held the Fortnite World Cup with a grand prize of $30 million US. These tournaments were streamed live on various platforms to millions of viewers. The video games that were played at these tournaments were labeled as electronic sports or esports. An esport is a multiplayer video game that is played competitively for spectators and is typically played by a professional gamer. These professional gamers are form part of these professional teams that compete and are often referred to as electronic athletes or cyber athletes. In conventional sports, strategizing plays a vital role. But where did these strategizing concepts begin? In previous years, games were played in a vital role in the military fields. They were being used as instructional tools in order to teach military officers about the principles of combat. Furthermore, these games have been used by the United States Navy in order to play these war games to depict possible encounters with various adversaries, to determine the best strategies and defeat these adversaries in the likelihood that they would meet one another in war. But even before this, the Prussian military required officers to play a board game called Kriegspiel. Having these military officers play Kriegspiel, a high command realized the vital information that could be gathered from playing Kriegspiel, as these individual officers might understand the principles of combat, but they might not know how to apply them when facing an adversary. By analyzing what happened during the game of Kriegspiel, they would understand the factors and the choices that influence the outcome of the game. Similarly, coaches do the same thing in sports. These strategizing concepts have now trickled down all the way to esports. Professional Counter-Strike Global Offensive esports teams often review their previous encounters with other teams in order to understand the faults that were made during the match, in order to learn from them, as well as to better understand their adversaries. By examining these other opposing teams, one would be able to determine their habits, their strengths, their weaknesses, leadership traits, aggressive and defensive responses that they may possess. By doing so, developing a counter strategy to exploit their adversary's weaknesses and defensive responses, much like generals in a war room when preparing for a battle against an adversary. Coming down to LabVIEW. What is LabVIEW? LabVIEW was the software that was used when developing the software for this study. The program that was developed was created within the LabVIEW 2018 programming environment. The LabVIEW programming environment also consists of two windows, the block diagram window and the front panel window. The block diagram window is a logical programming environment that uses a drag and drop principle. Within the block diagram window, the user will find the Functions tab. The tab allows the user to search for various things that they might need, such as function blocks that will help them program their software. This is simply done by dragging the function block into the function from the function tab into the window at hand. The front panel window is based off the same drag and drop principle as the back panel window. The primary role of the front panel window is to create a user interface or UI. It allows the user to control the inputs and monitor the outputs of the program that was created in the back panel window. What is image acquisition? Before any processing of an image can begin, an image needs to be acquired. An image that is acquired can be acquired in various ways, but the most common way is by the use of a camera in order to acquire an image. Once the image is captured, it is then stored in memory for later use. This investigation, there was no need for a camera, as the image that was acquired was done by the program of LabVIEW with the sole purpose of capturing the contents on the screen. Image processing. Image processing is the process of acquiring an image that is stored in memory. This image is then manipulated through various processes to extract features. These processes may include color thresholding, erosion, low-pass filtering, convex Hall functions, and pattern matching. What is color thresholding? Color thresholding isolates a specific color from an image, and in doing so turns it into a binary image. The way in which the binary image is constructed is a mask consisting of ones and zeros replacing each pixel, as seen in the figure below. Erosion. Erosion eliminates pixels isolated in the background and erodes the contours of the pixels according to the template defined by the structuring element. For a given pixel of P0, the structuring element is centered on P0. The pixels masked by the coefficient of the structuring element equal to 1 are then referred to as Pi. If the value of the pixel of Pi is equal to 0, then the P0 is set to 0, else P0 is set to 1. If and Pi is equal to 1, then P0 equal to 1, else P0 will equal to 0. Then the following structure will illustrate the effects of erosion. As can be seen here, the small particles will be eroded away, and thus leaving the more defined images. Low-pass filtering. Low-pass filters are used to filter out small particles based on their widths. The primary function is referred to as filter size. Having a filter size of a given size of n, the low-pass filter will eliminate any particles whose widths are less than or equal to n minus 1 pixels. These pixels disappear after n minus 1 over 2 erosions. The low-pass filter uses erosion to select particles to be removed. As the filter cannot distinguish between particles with a width of 2 times the pixel size or particles with a width of 2x minus 1 size pixels, the erosion cycle will eliminate both particles that are 2 pixels in width and 1 pixel in width as well, as can be seen in the image here. All the grayed out particles are then removed, as these are the primary ones that are left. Convex Hall function. The convex Hall function is often used to enclose particles that need to be measured. The most often use of the convex Hall is after passing a binary image through a low-pass filter, which introduces holes into the particles and thus make it difficult to generate a particle report. The convex Hall function calculates the convex Hall envelope around each particle and effectively closes the particle and filling each hole. This can be seen in the images below. Pattern matching. Pattern matching is a technique used for quickly locating known reference patterns within an image. Pattern matching can provide applications with information about the presence or absence of the number and location of a known reference within an image. There are 3 main areas of application for pattern matching, such as alignment, inspection, and gauging. There are various methods that can be implemented when tracking objects, namely mean shift or EM-based mean shift. Human motion analysis has also been the attention of computer vision for many years, with applications in various sports such as basketball and soccer. Methodology. To acquire and track players in an esport, the following steps were taken and programmed in LabVIEW in order to achieve our goal of player position extraction from the user interface of Counter-Strike Global Offensive. A multi-step algorithm that will be further elaborated upon is below. Image capturing. A program was written with the capability of storing a snapshot of the image being displayed on the monitor in memory temporarily. The image on the monitor is refreshed every second. This is known as frame rate and was captured and discarded every single second. The images captured were of the Counter-Strike user interface, and each snapshot was at the resolution of 1920 by 1080 pixels. This concluded the initial thread of the software. Pattern matching. This image that was captured in the initial thread of the program was then fed into a second thread of the program. This second thread had the sole purpose of processing the image and performing a pattern matching algorithm on the image to determine whether or not a specific element was present on the captured image. The pattern matching algorithm was trained to search for a specific template. The template that was created was from the round timer, which was found in the Counter-Strike Global Offensive user interface and served as a point of reference for storing data. Once a match was found, a score was given to the template and the captured image, as well as the number of matches the algorithm had found. With the match being found, an image was stored in memory, which was then discarded later. Color thresholding. Once a definite match was found, the image that was stored in memory was then fed into a third thread. This thread then thresholded the image to extract a specific color. As the two teams have their own respective colors, using color thresholding would be able to detect the T-sided players, as well as the shape detection would isolate the players from the in-game minimap and separating them from the background. Low pass filter. Once an image had been thresholded, it had been converted into a binary image, as explained before. This binary image often contains noise. This noise is then filtered out using a low-pass filter. With the image having been filtered, only the players will be left and on the image, and the background will have been removed. Convex hull function. Due to the low-pass filter being so aggressive in nature, the player models often were left with holes in them found on the in-game minimap. This is detrimental, as this often led to incorrect detection of players, and thus the convex hull function was used to resolve this issue. The image was then passed through a convex hull function and then stored in memory as well. Player position detection. With the image that has the players filtered out from the background of the in-game minimap and filled in using the convex hull, a particle report was then generated. The particle report generated an array of elements that are present in the binary image for a set of given parameters. The report includes the X and Y coordinates of all these particles, as well as their area and size. These coordinates and the area of the players were then stored. Experimentation. Experiments were done across all 7 maps that are used in the competitive map pool for Counter-Strike Global Offensive. These maps include Dust 2, Inferno, Mirage, Nuke, Overpass, Train, and Vertigo. A single match was downloaded for each one of these maps. Counter-Strike, as well as the player acquisition and tracking software written in LabVIEW, were run simultaneously. As seen on the screen is the UI for Counter-Strike Global Offensive while reviewing a match, and this is the in-game minimap that can be seen. This is the user interface for the LabVIEW software that was written in order to capture the in-game minimap. As can be seen in the center of the screen, this is the template used for the pattern matching, in order to determine when exactly to capture the image of the in-game minimap. This is the binary image that is generated by the thresholded image of the in-game minimap, as the region of interest has isolated. Each map was run for a total of 5 rounds to allow the program 5 attempts to capture data for a given map. Furthermore, a screenshot was taken at the exact time that the player acquisition and tracking system stored the players' positions. This was done for validation through manual review at the end of all 5 rounds. An example of this. Once the player positions acquisition and tracking software had run through all 5 rounds and stored the data, the program would stop automatically. The results were then tabulated and could be seen as follows. Each of the particles that were found in the binary image were displayed on the table, with 1 through 5, with the X and Y coordinates as well as the area. As can be seen in this table, the first particle that was found was determined to be the largest, and the program determined it to be 4 players. Through manual review, it was possible to see that it was 4 players. The accuracy was 100%. As seen in this enlarged image from the in-game minimap captured, 1 player was separated while 4 other players were grouped up together, thus giving it an accuracy of 100% when detecting players. The second particle was seen in this coordinate, with an area of 161 pixels. The program determined it to be 1 player. The manual review determined it to be 1 player, with an accuracy of 95%, as can be seen here. The rest were determined to be noise, as they were not large enough to be players. A second example of this can be seen in the image here. The table shows that the software predicted that there were 2 players at this coordinate with this sized area, and a further 3 players at separate locations, with the last being a non-player, as seen by its area here. The accuracy of the first 2 players was 100%. This can be seen in image 2 here on the right hand side, as well as the single players isolated on their own. This process was done for each one of the maps on each one of the rounds, and this is the overall tabulated information. As it's too large to be displayed one by one, I displayed it as all in one. Then it was summarized over each map's accuracy. As can be seen, the lowest was on Train and on Nuke. These are due to the maps having high verticality. What that means is it allows the players to stand one above the other. This is a strategy often done in Counter-Strike called boosting, and sadly this is one of the shortcomings of the software. In conclusion, the purpose of the investigation was to create a player acquisition and tracking system that stores the coordinates and the area of the players in order to study the positions of these players within the esport environment. This in turn led to the uncovering of the underlying limitation of such a system with regards to the esport of CSGO. The limitation was in the 2-dimensional axis. In future, a system could be improved upon to incorporate the 3rd dimension, and thus being able to fully track the players not only laterally and horizontally, but vertically as well, and thus negate the aforementioned limitation. In conclusion, esports is rapidly growing, with a viewership and prize pool being comparable to those of other sports such as cricket and soccer. It is difficult to believe that little has been done for player tracking and strategizing in esports, the aim of this study being to bridge this gap in the esports scene. Thank you.
Thank you.
Thank you.
So, are there any questions?
I see one question here in chat. Are you implement the image processing algorithm in LabVIEW? Yes, all the image processing was done in LabVIEW.
Okay. Another questions? Either by chat or directly?
I don't see anything else in chat.
Yes. There are no questions in the chat.
Did you listen to the question? Because I have here a question from Khawla Zawi.
Yeah, I saw it. Was it implemented? Are you implementing the image processing algorithm in LabVIEW? And yes.
Yes.
All the image processing was done in LabVIEW, yes.
Yes, okay.
Yeah.
You already answered to this question. Okay.
Yes.
Just a question, perhaps not very related to your work, but just these algorithms and techniques that you used in this for esports.
Yes.
I'm just asking if it is possible to apply them to another field or another context.
When actually doing the testing for the paper, actually, we did do tests on something like soccer. We did on cricket and rugby, and it actually was able to pull certain players off the field. So you could actually define a specific team that you would like to analyze. So say, for example, it's the All Blacks from New Zealand in rugby. It will isolate their players on the field and you'd only be able to track them using my software.
Perhaps my question is beyond the games.
Sure.
Perhaps in reality, so for tracking people.
Yes, no, definitely it
or-
would. But what it does, seeing as it mostly like you can specify the color that you'd like to track, it's more tailored towards tracking specific colors as teams use specific colors. So if an individual is wearing a specific color, it would definitely be able to track them, yes.
Perhaps in the case of France, they have the Gilets jaunes.
Yeah, true.
Okay. Thank you. Are there any other questions? I think there is no more questions.
All right, thank you
Perhaps
so much.
Professor Lej?
I think just check. There we go.
Okay, I see there is no question. Okay, thank you. Thank you for your presentation. Thank you very much.
Thank you for your time.
And next presentation is Karim El-Mutawakkili, Abdellatif El-Wisari, Abdullah Touhafi, and Nabil Ahran. Are you in the room?
Welcome, sir.
You are here. Okay. Okay. So you will present density-based support vector machine by Karim El-Mutawakkil, Abdellatif El-Wisari, Abdullah Touhafi, and Nabil Ahran. Go ahead. You have a video, or you are going to use your screen?
I have a video in my computer.
Okay, go ahead.
Give me 1 minute, sir.
Okay.
Salut tout le monde et bienvenue exposé concernant density based support for machine TPSVM présenté par en collaboration avec le professeur Karim.
The audio is not clear.
If you can increase the sound, please.
Yeah.
Salut tout le monde et bienvenue exposé concernant density based support for machine TPSVM présenté par Dr. Mistari en collaboration avec le professeur Karim Mutawakkil, professeur Abdullah Tahadi et M. Nabil Ahran. Avant de commencer notre exposé, je veux remercier tous les membres de GreenTech pour leur grand effort. Alors, notre exposé comme ceci. On va commencer par une introduction. Vous pouvez voir
I'm sorry, but it's difficult to hear. Or the audio is very, very loud or very bad.
We're not able to understand what you say.
Could you just comment the slides?
Sorry, I don't understand.
You can comment if you can't. If you're not able to comment in English, you can comment in French. As you have in the video. Non, ça marche pas. Okay.
Mr. Abdelatif? Mr. Abdelatif? Did you have any problem with your machine? With your laptop? Perhaps it's problem of quality of connection?
Maybe. Okay. I think that there is some problems. So I propose that maybe we can go to the next presentation.
Yes, and we can return back to
Yes,
this one.
maybe in the end of the session, we can try to contact Abdelatif.
I
Okay.
think it's a bit. So,
Okay,
yes.
okay. So we have to contact to say, please, the room manager, if you listen to us, please
Yeah.
try to stop.
We'll move.
We'll move, yes. Okay, so the next presentation.
Yes.
Okay, the next presentation is a business process modeling notation extension for real-time handling application to novel coronavirus management process. The authors as Asma Orhim, Jihan Lakhrouit, and Karim Beina.
Yes.
Go ahead. You have a video, or are you?
No, a presentation. I will present.
Okay.
Yeah.
Please share your screen.
Yeah. So hello everyone, I'm Asma Warhim. I'm from National School of Computer Science and System Analysis, Mohammed V University in Rabat. Today I will present you the work I did with Professor Jihan Lakhrouit and Professor Karim Beina from Advanced Digital Enterprise Modeling and Information Retrieval Laboratory, Rabat IT Center in CS. So today I will present modeling notation extension for real-time handling application to novel coronavirus management process. So by outline of the presentation. So after an introduction, I will present you our own definition of real-time And then I will present you real-time process and real-time enterprises definition. And before conclusion and outlooks, I will present you our contribution that contain 3 elements. The first one is real-time ontology, and the second one is the additional real-time component BPMN, and the third one is our application to coronavirus management process. So time is one of the most treasured resources in all companies and in different domains. It is important to react at the adequate moment, and any latency may cause many problems as the financial one and losing customer satisfaction. In our lifestyle and customer satisfaction goal, real-time business process is one of the important components of real-time enterprise. For that, a formal definition of real-time concept and real-time process was indispensable. In BPMN, time constraints are implemented and modeled by the event time entity, which is in the most cases sufficient to manage them. However, real-time concept is not modeled or implemented. Companies' needs are increasing in all axes, namely the time axis, known by its sensibility and importance. Companies need to check the temporal properties of business processes, such as the execution time of an activity, the minimum and maximum time constraints, but there is no attribute to specify them in BPMN. And at the same time, we cannot set time for staying not feasible. This work presents a formal definition of real-time concept, real-time ontology, and a proposition of a real-time component with real-time attributes. Before the proposition of real-time component for BPMN language, which we apply to novel coronavirus management process as case study. So coming to real-time definition. Real-time means right now, but in real life, it gets its definition from customer needs. So if an hour from now is good enough, that's become the definition of real time. Since the real time is not attainable in its full meaning, a reaction at the right time will be beneficial. Having the right information addressed to the right person at the right time. Indeed, in an ideal world, organizations will react instantly to business needs. In reality, this is not possible. So we talk here about real time, near real time. The key concept of this vision is to minimize the time between the moment when data is stored and the moment when it's available, named time latency, during the whole process. The idea is to have as a decision maker pertinent information and quickly. This latency depends on business user reaction time and the technologies used to deploy real-time processing BI application. So coming to the real-time process. Real-time processes are processes which have real-time characteristics. Real-time process is one of real-time enterprises characteristics. In a business process, time takes different forms, but there is no definition of real-time concept. We can define time in a business process as a duration, a point, no, or a condition. So as a duration, in general, it is an interval with two ends in processes and tasks. As a point, it can be a moment of execution of processes or an execution time of tasks. No, in general, it is not a reaction. And as a condition, we react in general according to condition. So coming to the definition of real-time enterprises. So real-time companies have a system with rapid reactions, usually automated according to embedded system rules or some technological solutions. We can summarize the characteristics of real-time company and define it formally as agile, rapid reaction, delivery of information, fast data analysis, real-time process management, or using new technologies which all gathered in latency equals 0. So coming to our contribution, we start with the real-time ontology. So the first step was to find the formal definition of real-time concept. We already talked about near real-time. So the key concept of our vision is to minimize time between the moment when data is stored and the moment when it's available, named time latency. The idea is to have as a decision maker pertinent information and at the right time. Since the real time is not attainable in its full meaning, reaction at the right time will be beneficial. So having the right information addressed to the right person at the right time. So according to our approach, there is a need of an acceptance interval and a theoretical time when we face time in a real-time process. The acceptance interval can be defined as customer satisfaction interval, and the theoretical time is the ideal time that should be predicted by using the different tools of prediction. So according to this result, we can define real-time formally as real-time ontology equal time ontology plus 3 attributes. The first one is latency, the second one is the acceptance interval, as we said before, and the third one is theoretical time. So the figure below shows our adapted version of ontology time proposed by Kirikova, and we had our 3 attributes. So the figure below is our proposition. So this adapted version adds a new dimension of time to time ontology, which is real time. This new dimension contains 3 components: latency time, acceptance interval, and theoretical time. This definition gives a new vision of time, not just an ordinary vision as periods and calendar, but as a response to our needs in our real-time enterprises that is real-time. So latency is the first attribute in this definition. As we had already mentioned, real-time is not attainable in its full meaning. So time latency is reliable to the definition of real-time. It can be defined as an interval. So our definition of real-time is related to client need. For that, it was necessary to define a new attribute which will frame in a safe interval of latency. So we had defined the second attribute, acceptance interval. So acceptance interval is defined as interval 2. It represents the interval of safety in which latency will not affect the flow of the process. Theoretical time is our projection in future of our results. So the goal of defining this theoretical time is our need to compare results, to identify how much we are far from the ideal result. In general, theoretical time is considered as an ideal result, and the upper bound of the acceptance interval as the worst result, so the lower bound will be the theoretical time. So the second is our last contribution is the additional real-time component of BPMN. So we are interested by components that have relation with time. So after a large analysis of BPMN specification, we found that event is our interest. The figure below is a metamolar diagram with our interest has a direct relation with flow node, but indirect relation with activity through boundary event and specifically catch event. So event and activity inherit from flow node, which inherit from flow element. The component process inherit from flow element container, which is a composition of flow elements. So as we see, and as the definition of time in a process shows, activity is only by time and world process too. We propose to create a new component real-time attributes that contain these 3 attributes: latency, acceptance interval, and theoretical time. So the figure below presents So this is the prototype of our proposition that contain our real-time attribute. So before that, I must add something about. So this this component will let us to have more information and control into our real-time processes. So this definition will give us another vision of processes and a more clear vision to what a real-time process. So to what is a real-time process. So this is our application to coronavirus management process. So the general process of assess 2009 novel coronavirus, we choose BPMN as language for our study. The figure below shows the general process of assess 2009 novel coronavirus. It contains 3 sub-processes: identify, isolate, and intensive care. So we are interested about these 2 sub-processes: identify, isolate, as real-time processes, so as risky real-time processes. So for the patient safety and order in his entourage too. So we applied our proposition to coronavirus process. The idea is to have a clear idea about the development of time during the process. Real-time concept is always needed in cases when we have maximum risk. For that, we present a new version of processes with real-time component. The figure below presents identify process. Fulfilling patient information must not take much time. So there is a need of real-time component. Test fever also and symptoms of lower respiration illness must be done on time without a large time latency for patient safety. So real-time component is needed here too, to have a clear idea about the progress of our process. And finally, another one in sub-process. As activity type, we need to take information time about the whole process too. The same thing with isolate process. We put real-time component on activities where we have maximum risk for more precision concerning time latency on activities to minimize the risk, as isolate in a patient immediately. The same thing with assess clinical status and decision disposition to know patient status quickly before contacting health department to report the clinical status of patient to assess, which need to collect specimens for test of coronavirus, which must be done on real time. So as a conclusion and outlooks, this work presents a formal definition of real-time concept, real-time ontology, and a proposition of real-time component with real-time attributes. This new dimension of time contains 3 components: latency time, acceptance interval, and theoretical time. This definition gives a new vision of time, not just an ordinary vision as periods and calendar, but as response to our needs in real-time enterprises, so as a real-time. And this definition will facilitate also the interaction and the use of real-time concepts, the different studies needed to improve the different domains, time domain. And a proposition of real-time component for BPMN language in a way to identify and define real-time processes and a way to control and monitor real-time processes that was applied to novel coronavirus management process as case study. So as outlooks, we aim to define this definition through enterprise architecture. So thank you for your attention, and I'm waiting for your precious remark and ideas about my work. So thank you.
Thank you very much.
Welcome.
I Didn't see any question in the chats. Are there any question in the audience? So I have just a remark about the use of the concept of real time.
Yes.
I'm just wondering if it's instead of real time, it's question of near real time.
Yes.
Particularly for the example of dealing with the patients with the coronavirus.
Yes, it's a good question. So the definition of near real time, it's because we cannot define real time as the ordinary definition as at the moment, because we cannot attend this definition. So we propose to give this definition of near real time to give this maximum risk of the delay. So when we talk about near real time, is that we put this maximum risk of delay. So we try to not pass this delay. So we say that if we are in this interval of safety, so we cannot have any problems later.
I see, but just you know, this term of this concept of real time is always linked with seconds of in terms of times of response of the system, for example. So
yes.
perhaps it's a delay sensitive processes.
Yes,
because they
so,
are really
yes.
sensitive about delay, but it's not in terms of seconds, perhaps minutes.
Yeah, I see. So this definition is not like it's like so my work is that I'm giving a new definition of real time in another domain. So we already have the definition of real time in the domain of systems, but here I give another definition in domain of management, in another domain. So I say that real time in yeah.
Yes, I get the point,
Yeah.
but just to avoid confusion in the title by
Yeah,
other issues in fields. So
yes,
perhaps
it's important.
Could be better, but just a remark.
Yes.
It's not mandatory remark.
Yeah,
Are there
thank
any
you.
other questions?
Yeah.
I think it's one question.
Yes, please. I agree with Professor. There's a problem here. I think you used a component what is called real time. Maybe it you have to use maybe a component which is called time, and in this component maybe you can have many attributes, and then you can have a real time among them. I think because real time effectively it's a specific terminology for system. I think it was not a question, it's only a comment.
Okay, I noted that. I think it's a good remark. Yeah, because I already have the same question from many people. So it I think I must change the terminology of my proposition.
Delay sensitive, perhaps delay sensitive, or
yeah. Okay. Thank you.
There is a question in the chat. So it's about difficult. Was it difficult to obtain the data needed for the study?
Yes, absolutely. Because yes, I had many problems because I had did already another study in my previous work about this real time, because I proposed previously an algorithm that used these three attributes, and I've used some data to have some results. But I had some problems to find data because I need a specific data to did my studies. So yes.
For the case study of coronavirus or other?
For this case study, yes. For other case study, yeah.
Others. I think there are no more questions. So Professor Lilij, perhaps we should move to the next one.
Exactly. So the next presentation is a model of biometric recognition system based on the Hopf transform of Libor, mask, and one-dimensional log-Gobber filter. The authors are Jalal Rafiq Hamou, Sidi Ahmed Mahmoudi, Rida Jouj, and Boubacar Mchab.
Est-ce que vous m'entendez? Salam alaikum.
Alaikum salam, parfaitement.
Donc, je peux commencer?
Oui, go ahead.
Est-ce que l'écran est visible pour tous?
Oui. Yes.
OK. Bismillah ar-Rahman ar-Rahim. Wa salatu wa salam ala ashraf al-mursalin. Donc, je vais présenter mon article qui s'intitule A Model of Biometric Recognition System based on the Hopf Transformer of Libor Masak and what the Gabor filter. Donc, je prépare ma thèse de doctorat au niveau de l'université de Sidi Bel Abbas avec la collaboration de l'université de Mons, de Belgique. Donc, je présente mon article par moi-même et par M. Sidi Ahmed Mahmoudi de l'université de Mons, ainsi que mes deux collègues, M. Adjouj Rida et M. Boubacar Mchab de l'université toujours de Sidi Bel Abbas. Donc, nous allons commencer par un plan de travail. Donc, je vais commencer par une introduction générale. Ensuite, je vais entamer le domaine biométrique. Par la suite, je vais exposer la modalité de l'iris. Ensuite, nous exposons notre approche. Ensuite, je vais exposer qu'est-ce que ça veut dire un système de reconnaissance d'iris. Ensuite, le dataset, c'est-à-dire les bases de données d'iris. Et je vais exposer mes résultats que j'ai obtenus. Et je terminerai, Inch'Allah, par une conclusion. Donc, concernant l'introduction générale, donc la masse de données multimédia qui existe dans l'Internet et dans l'intranet est très volumineuse et elle concerne beaucoup de domaines tels que l'imagerie médicale, le domaine satellitaire, la géologie, l'astronomie et la recherche biométrique. Cette masse d'informations, il faut pouvoir la représenter sur des supports de données tels que des bases de données. Alors, ces bases de données peuvent être de différents formats. Donc, on peut trouver des bases de données de type texte, des bases de données de type son, vidéo et images. Alors, les bases de données de type image ou bien les bases de données de type son ont des spécificités particulières. Donc, elle a pour but de la génération, c'est-à-dire elle produit des outils d'utilisation, la représentation, sur quel type de format elle peut être définie, le stockage, quels sont les supports de données utilisés, tels que des disques durs, la transmission, l'utilisation des supports de transmission, les problèmes de connexion et le type d'architecture. Et elle concerne aussi la recherche d'informations, telle que la recherche d'informations basée sur le contenu et aussi la distribution, telle que la technologie de streaming qui est utilisée dans des serveurs. Toujours dans l'introduction, donc le domaine biométrique veut dire la mesure du vivant. Alors, dans le domaine biométrique, il existe deux techniques pour permettre de reconnaître l'individu. Donc, il y a la technique d'identification et il y a la technique d'authentification. La technique d'identification, elle permet de détecter l'individu en essayant de l'introduire une première fois dans la base de données. Par contre, la technique d'authentification, c'est le contraire, c'est-à-dire l'individu il est enregistré dans la base de données, donc il y a simplement une petite formalité à faire. Donc, ça peut rentrer dans le domaine de temps d'exécution, la base de données, le volumineux, etc. Donc, ça rentre dans le domaine de la complexité. Aussi, une autre information, donc les données biométriques sont propres pour chaque être humain vivant sur Terre. Alors, il existe deux différents types de biométrie dans la littérature. On peut trouver la biométrie morphologique, c'est-à-dire physiologique, telle que l'iris, les empreintes digitales, le visage, les réseaux veineux de la paume de la main, les oreilles, l'ADN, le poids, le cheveu. Donc, il existe plusieurs modalités. Un autre type de biométrie, c'est la biométrie comportementale. Donc, elle concerne la façon dont l'être humain traite les choses. Par exemple, il y a sa voix, la façon de taper dans un clavier, la façon de signer, la façon de marcher, donc, etc., etc. Donc, on peut représenter ces différentes modalités. Donc, on peut trouver l'iris, les empreintes digitales, on peut trouver le visage, la géométrie de la main, la rétine, la signature, le poil, l'ADN, le sang. On peut trouver la thermographie faciale, on peut trouver beaucoup d'autres choses. Donc, dans ce slide, on peut remarquer les différentes modalités existantes dans la littérature. Donc, il existe d'autres modalités, mais ce sont les modalités les plus utilisées. Alors, pour évaluer un système biométrique, donc, il faut prendre en considération certains critères tels que la précision, l'efficacité, donc en termes de temps d'exécution, la fiabilité, est-ce que le système est fiable ou non, le coût, le coût, par exemple, le coût machine et le coût logiciel et le coût matériel. Il y a aussi la quantité d'informations stockées pour chaque personne. Toujours dans le domaine de l'évaluation, donc pour évaluer un système biométrique, il faut prendre quelques critères. Parmi ces critères, on peut trouver le false acceptation, c'est-à-dire les faux acceptations, c'est-à-dire qu'une personne authentique, elle est acceptée par le système, mais quand on va faire la revérification, elle est rejetée. Et il y a les faux rejets. Donc, les faux rejets, c'est-à-dire c'est un imposteur, mais le système ne le rejette pas, c'est-à-dire le système il l'accepte. Donc, c'est un problème qu'il faut régler. Toujours dans le domaine de l'évaluation biométrique, donc il y a deux critères très importants. Il y a le FAR, False Acceptation Rate, et il y a le FRR, le False Reject. Donc, le False Acceptation Rate, c'est le nombre de personnes authentiques sur le nombre c'est le nombre d'imposteurs acceptés par le système sur le nombre total d'imposteurs. Et le false reject rate, c'est le nombre de personnes authentiques rejetées par le système sur le nombre de personnes authentiques. Alors, pour évaluer un système biométrique à identification, il faut prendre trois critères très importants. Il faut connaître la base biométrique de données. Il faut prendre le nombre de personnes qu'on veut utiliser pour mesurer l'efficacité du système quand on va faire le test. Il faut toujours prendre en considération le troisième point qui est important, le nombre d'imposteurs qu'on va utiliser pour voir la robustesse du système. Donc, si on veut calculer le taux d'identification, donc il faut prendre le nombre de tests total qui ont donné de bonnes identifications sur le nombre total de tests. Alors, la modalité de l'iris. Donc, dans cet article, je vais consacrer mon approche sur la modalité de l'iris. Donc, la modalité de l'iris, c'est une modalité très complexe parce que pour la détecter et pour pouvoir faire la segmentation et extraire l'information pertinente, donc on va utiliser beaucoup d'algorithmes mathématiques. Donc, le premier qui a abordé l'idée de la modalité de l'iris comme technique de vérification d'un système, c'est le phalmologiste Frank Birch en 1936. Donc, c'est lui qui a proposé l'idée d'utiliser la modalité de l'iris comme une technique d'identification. Alors, un troisième point important dans la modalité de l'iris, c'est la localisation de l'iris. Donc, pour pouvoir localiser de l'iris, il faut premièrement localiser la région de l'œil de l'humain. Donc, après la segmentation, il faut pouvoir extraire l'iris de l'œil de l'humain. Donc, il y a deux étapes importantes. Et pour pouvoir le faire, il faut utiliser des outils mathématiques spécifiques et adéquats. Alors, la proposition de notre approche va se concentrer sur 5 points importants. La première, on va utiliser ce qu'on appelle le filtre de Gabor en utilisant la distance de Hamming ainsi que l'opérateur XOR. Le deuxième point, nous allons utiliser notre approche sur deux bases de données qui s'intitulent MMU1 et Casia version 1. Le troisième point, nous allons collecter les informations de notre expérience sur les deux bases de données en utilisant les critères d'évaluation tels que le FAR, le FRR, le ER et le Overall Accuracy. Le quatrième point, nous allons comparer nos résultats obtenus avec les différents outils et les méthodes utilisées dans l'état de l'art avec les articles de Martin Roche, de Lima et al., Tis et al., Lieber-Mazak, Rai et al., Derkerdi et al. Et Suleiman et al. Et pour terminer, nous allons aborder une discussion sur les résultats que nous avons obtenus et les perspectives de recherche que nous allons aborder dans un futur proche. Alors, exposons, qu'est-ce que ça veut dire un système d'acquisition des risques? Alors, un système de reconnaissance des risques, il est basé sur 5 points importants, ou bien sur 5 étapes importantes. La première étape, c'est l'acquisition. Donc, elle consiste à capter l'œil de l'humain en utilisant l'individu, un capteur d'écran et l'image que nous allons capturer. La deuxième étape, c'est la segmentation. Donc, pour pouvoir extraire la région de l'iris, nous allons utiliser 2 cercles concentriques avec une étude mathématique spécifique. La troisième étape, c'est la normalisation. Donc, cette étape permet d'extraire la région de l'iris et de la transformer de la forme circulaire en une forme rectangulaire. Nous allons pouvoir utiliser un autre point important de la normalisation, c'est improvement. Donc, le improvement, c'est un outil en machine learning qui permet d'améliorer la qualité de l'image en éliminant le bruit. La quatrième étape, c'est l'extraction de caractéristiques. Donc, l'extraction de caractéristiques, elle permet d'extraire les informations pertinentes de l'image normalisée en un vecteur binaire pour pouvoir la traiter. La cinquième et dernière étape, c'est la comparaison et le matching. Donc, nous avons le vecteur caractéristique de l'individu. Donc, nous allons comparer la requête d'image avec la requête de la base de données en utilisant une distance de Hamming. Donc, si la distance, par exemple, elle est proche de 0, donc ça veut dire que la personne, elle est authentique, elle fait partie de la base de données. Sinon, si elle est proche de 0,25, donc c'est un imposteur et cet individu ne fait pas partie de la base de données biométrique d'IRIS. La première étape, c'est l'étape d'acquisition. Donc, pour pouvoir capturer une image de l'œil de l'humain, donc il faut prendre des critères très importants, tels que la distance entre l'individu et la caméra, qui doit être par exemple entre 30 et 60 cm. Il faut que l'utilisateur aide le concepteur qui va capturer l'image de l'iris en ouvrant l'œil et en gardant la tête fixe. Et l'œil doit rester le plus proche de l'écran en essayant de ne pas bouger. Le troisième point important, c'est d'utiliser une chambre qui isole les bruits, tels que le reflet du bruit de l'écran, le bruit extérieur, le reflet, par exemple, des objets, le soleil, etc., etc. Donc, tous ces objets ou bien tous ces outils peuvent influencer sur la qualité de l'image de l'iris. Un autre point important, c'est l'utilisation d'un appareil d'acquisition très spécifique pour la capture de ce genre d'image. Donc, les plus utilisés dans la littérature, nous avons 2 caméras telles que Nikon E5700 et l'appareil d'acquisition LG Iris Access, qui est dédié spécifiquement pour la capture d'images d'iris de l'œil humain. La deuxième étape, ou bien toujours dans l'acquisition, donc on peut remarquer dans ce slide la différence entre une bonne qualité de l'image à droite et une mauvaise qualité de l'image à gauche. Donc, on peut voir par exemple, il y a le reflet de lumière infrared LED, il y a par exemple les cils inférieurs et supérieurs de l'image, et il y a aussi les paupières inférieures et supérieures. Par contre, dans l'image droite, on peut voir que la clarté de l'image, elle est très nette. Les paupières inférieures et supérieures sont ouvertes, l'iris, elle est claire, il n'y a pas de reflet d'image. Alors, pour l'étape de la segmentation, nous avons utilisé la transformée de Hoover de Lieber-Mazak. Donc, cette technique, elle repose sur la formule du cercle de la droite, telle que X, C, Y, C représentent les positions de l'abscisse et de l'ordonnée du centre, et le R, c'est le rayon de l'iris. Donc, le concepteur de cette méthode, il s'appelle Richard Paul White. Donc, c'est un éminent-chercheur à l'université de Cambridge. Donc, c'est en même temps un informaticien et mathématicien. Cette méthode a été implémentée en 1995. Et le deuxième point important de cette méthode, c'est la deuxième fonction. Donc, il a utilisé la transformée de Fourier en basant sur les coordonnées polaires, telles que sinus θ de J et cosinus θ de J, tel que θ, c'est l'angle utilisé pour la capture de l'image de l'iris. Le troisième point important, c'est la normalisation. Donc, la normalisation, elle permet de changer la forme géométrique de l'iris en une forme rectangulaire, telle qu'en prenant le rayon et l'angle utilisé comme paramètre de longueur et de largeur. Ou bien, dans une autre définition, le modèle permet de transformer les coordonnées cartésiennes il permet de transformer les coordonnées polaires en coordonnées cartésiennes. Et cette méthode a été utilisée par le modèle de Radoshi de John Dogman. La quatrième étape, c'est l'extraction de caractéristiques. Donc, on peut voir dans cette image 3 images. Donc, A représente l'image normalisée que nous avons obtenue de l'iris. L'image B, elle représente l'extraction de caractéristiques, c'est-à-dire le filtre que nous avons obtenu. Et l'image C, c'est le masque que nous allons utiliser dans le matching qui va permettre de détecter l'individu, est-ce que c'est un imposteur ou non. Alors, la 5e étape du système de reconnaissance d'iris, donc c'est la distance de Hamming. Donc, la distance de Hamming, donc c'est une distance normalisée. Donc, on peut voir, donc c'est 1 sur 1 l'ensemble de X XOR YJ. Donc, XJ représente la requête d'image et YJ représente la requête de la base de données. Donc, en utilisant une opération mathématique et une sommation avec l'opérateur XOR, donc nous allons obtenir une distance. Donc, si la distance elle est proche de 0, ça veut dire l'individu il est authentique. Sinon, elle est proche de 0,5, donc c'est un imposteur. La deuxième équation, donc c'est l'utilisation du masque. Donc, nous allons utiliser le masque toujours de la requête d'image, elle est représentée sur code A, et les masques de la requête de la base de données, code B, en utilisant l'intersection, donc toujours avec l'opérateur de la première extension et la deuxième extension, qui vont permettre d'obtenir la distance qui s'appelle la distance de Hamming. Alors, les bases de données que nous avons utilisées, donc dans mon approche, donc j'ai utilisé 2 bases de données. La première base de données, un certificat Kaseya version 1. Donc, c'est une base de données chinoise. Donc, on peut voir un extrait sur le slide. Donc, le nombre d'images, c'est 756 images. La dimension, c'est 320,280 pixels. Le format, c'est BMP. Et l'appareil d'acquisition utilisé par ce laboratoire, ça s'intitule Kaseya Close-up Iris Camera. La deuxième base de données, c'est une base de données de l'université américaine. Ça s'appelle Multimedia University One. Donc, nous pouvons voir un extrait dans le tableau. Elle contient 450 images, format 320,240 pixels, JPEG, et l'appareil d'acquisition, c'est LG Iris Access 2200. Alors, les résultats que nous avons obtenus, donc les résultats que nous avons obtenus pour la base de données Kaseya version 1, donc ce graphe permet de voir la distance de Hamming et la distribution interclasse et intraclasse. Donc, en rouge, on peut voir la distribution intraclasse et en vert, on peut voir la distribution interclasse. Et l'intersection des deux distributions vont pouvoir de trouver le seuil EER.
Il vous reste 2 minutes pour conclure, s'il vous plaît.
Il n'y a pas de problème. Le deuxième graphe permet de détecter le seuil que nous avons utilisé. Donc, pour la base de données Kaseya, donc c'est 0,05. Le troisième graphe permet de voir la distribution de la deuxième base de données. Donc, toujours la distribution interclasse en violet et la distribution interclasse en marron. Le quatrième graphe permet de trouver le seuil que nous avons utilisé dans la base de données MMU1. Donc, les deux intersections de FAR et FRR permettent de trouver le seuil qui est trouvé de 0,34. On peut voir dans le cinquième graphe la courbe ROC telle que la distribution FAR de la base de données Kaseya et la base de données MMU1. Et enfin, nous avons les résultats que nous avons obtenus dans notre recherche avec les différents résultats obtenus dans la littérature. Donc, nous pouvons voir dans la dernière ligne de tableau que nous avons utilisé notre approche et que nous avons obtenu un score de 99,92% de test accuracy. Et dans la base de données MU1, nous avons trouvé un meilleur score, 99,41%. Et dans la dernière colonne du tableau, on peut voir la différence entre notre approche et l'approche proposée par les différents articles proposés. Pour terminer, donc, dans un futur proche, nous proposons d'utiliser la technologie du deep learning en utilisant les auto-compteurs qui vont permettre de faire la segmentation et de trouver la personne authentique et de trouver aussi la comparaison entre la méthode classique et la méthode de deep learning et de comparer les deux approches. Je vous remercie. Assalamu alaikum wa rahmatullah.
Thank you for this interesting presentation. I think there is some questions. I see question from Professor Vieira. Can you ask your question, please? Joaquim Vieira. Okay.
Or we can read the question.
Yes, please. Okay.
Could the system still detect the iris with people that have contact lenses, or would it struggle?
Please repeat your question.
Sure. Would the system still be able to detect a person's iris even though they have contact lenses, or would it struggle?
Mr. Rafiq, did you hear the question?
Je n'ai pas bien entendu la question. J'ai simplement étudié le système iris detection for. Je n'ai pas bien entendu la question.
The question is already in the chat, and it's about the contact lenses, les lentilles de contact.
Je vais essayer de parler en anglais. For the application, the system recognition iris, I don't use the lens contact for the person. The person does not use the contact. The specification for the database iris are the individu are not use the net and do not use the lens contact.
Okay. The other question is, if the iris is dilated, so the pupil obviously contracts and dilates, is the system still accurate even if it's dilated, or is there maybe a drop-off if the pupil is dilated or not? In accuracy, obviously.
Okay.
Did you hear the question about dilatation? Or?
Mr. Jalal?
Yes.
Did you? We are waiting for your answer.
You are asked the question?
Yes. Yes. Mr. Vieira, can you repeat your question,
yes,
please?
Yes, I can. If the iris is dilated, is the accuracy still high, or does the accuracy drop off if the pupil is dilated?
You are a question for the test accuracy?
Yes. Non, si l'iris est dilaté, est-ce que vous avez obtenu la même exactitude ou non?
The specificity, your question under the consideration for the quality for the image. The two database used are not used the image. For example, the dilatation for iris patient.
100%. Thank
But
you so much.
if I could interfere here, in the cases of you have a pre-processing that could normalize and apply some techniques to the image. So at the end of the pre-processing, perhaps it will be like the image without dilatation.
For the future work, I construct the private database, but the used database is very difficult because in the literature that exists two types of database: database free and database not free. I'd use the two database free. Database Casia, it is a very large used in the interesting and used the book. A lot of chercheurs use the database Casia because the database is not color and very clear and simple for clarity for the image database. But the database is 1.1 it's the difference for the first database is format image and size the image, but a lot of the two database Casio 1 and MMU1 that very clear for ease and simple used person.
Okay.
But in future work, in the laboratory, I construct the specificity for the database and the consideration number criteria tels que the nets, the percent, and the dilatation for the iris, and the noises for the image for class T on image, because the process for the application in the system collocation series that parental consideration a good quality image and not quality image. If a good quality image that obtain a very good result, but it use the bad or low quality image at a very problem for the different steps, the segmentation of normalization, and finally that not good very test accuracy and systems.
Okay. Are there any questions in the audience? No more questions?
I will present for excuse for the presentation in French, but I will make in the future conference that default for talk in English, inshallah.
Yes, you speak very well in English.
So it's preferable to speak in English, even if we have some problems of pronunciation. No problem with that.
But I the first, but I never present the conference in English. But I under consideration remark and we'll make the effort for presentation in the next conference, inshallah.
Inshallah.
Okay. Okay, I think it's okay. Thank you very much. Thank you very much, Mr. Jalal Rafiq.
There is another question. There is another question in the chat.
Pardon?
In the chat, I think, did you think about time of recognition? I think it's for you, Mr. Jalal.
I prepare the next article and the conference with use the implementation in the deep learning and the method classics, the comparison entre the two techniques with the deep learning and the method classics for presentation I know, and the consideration the time, the process, and the time of the first steps in the last steps for the time process, because the system is used in the airport, for the plane, for the level. Is a very good question. It's a very good question. For the next future, I used the time for the locate image and locate the image in database.
But I think the question is about recognition, not for the acquisition of data. It's for the recognition when we use the system to authenticate people that are already.
I don't use the time. I don't use the time. If the criteria for evaluate the system, I don't use the time.
Okay, thank you.
Okay.
Okay.
But the very good questions. The very good questions.
Okay. Okay. Thank you again. And I received a message from Abdulatif. He's ready to present his work.
Great.
So it will be the last presentation. Abdulatif, do you hear me? Are you here, Abdul Latif? C'est pas extraordinaire.
I think you still have the problem.
No, real problem.
Perhaps it's also problem of the quality of the connection, the internet connection.
Yes, yes, I think so.
So if you could use another 4G or you move in the place where we are, perhaps you will have a better quality. Mr. Rafer, could you please stop the sharing of your screen?
Okay, Abdul Latif? No, I don't. We don't hear you well.
And
So,
we didn't screen either.
I think that's we tried, but it doesn't work. So I would like to thank the audience and all the speakers, and have a nice day. Okay, thank you. Thank you for.
Thank you.
Thank you so much.
Okay.
And perhaps for the Abdul Latif, we could
Thank you very
try with manager to be scheduled in another session tomorrow, perhaps.
Maybe. Yeah.
Maybe possible.
Okay. Okay. Thank you all.
Thank you, Professor.
Thank you very much.
Bye bye.
Thank you.
Au revoir.
Thank you, Professor Esh.
Thank you. Merci à vous, Madame Professeur.
À la prochaine.
Inch'Allah.
Bye. The conference manager, we finished this session, so.
Ok, on va sortir de là.